Peace be upon everyone and welcome if this is your first time, and if it is not your first time, welcome back. So today we're going to be working on achiral molecules and chiral molecules, and I'm going to be teaching you the differences between both. And when we're done with that, we're going to practice the questions on the right. So I'll advise you to stay tuned to the end of the video in order for you to know um the answers as well as get the full benefit of the video. So now let's start. The thing you have to understand is that achiral molecules, anytime you're given a molecule, you have to determine whether it's achiral or chiral. So in order for you to know whether it's achiral, there are two things that you have to search for. The first is that you have to make sure that two or more of the same atoms or groups are attached to the main center. So, for example, say the main center is, say, P. If you have two or more of the same atom that are attached to the center, because whenever you're dealing with like molecules or you want to determine whether it's chiral or achiral, the center has to be attached to four different atoms, because you're dealing in whenever you're dealing with chirality or non-chirality, you're dealing with tetrahedral structures. So that means they have three different attach sorry that means they have four different attachments to a center. So whenever you have two or more, that means that molecule is achiral. Now, the second thing is you also have to check if the molecule has a plane of symmetry, because molecules that have a plane of symmetry, or a line that basically bisects a molecule in such a way that the both sides that is separated by that plane are mirror images of one another, that is a plane of symmetry. And I'm going to show you guys when we start doing the problems. Now, the next thing you have to know after you've understood this is that you have to look at chiral molecules, and chiral molecules are just the exact opposite of achiral molecules. The first thing for chiral molecule is that you have to have four different atoms or groups attached to the stereo center. You know how for achiral, if you have two or more of the same atoms or groups, that makes it achiral. But for chiral, you always have to make sure that all four atoms or groups are different in order for us to call that a chiral molecule. But that does not end there. You also have to make sure that there's no plane of symmetry. And honestly, when you do a lot of problems, you realize that like whenever you have like four different atoms or group in a tetrahedral structure, there's usually like no plane of symmetry anyways. So, but you're gonna see that more when we start like working. So the first question is number one. We have this structure here. You have a CH3 here and a CH3 here. And we're going to look at each carbon center. First of all, this one is not a carbon center. Is not a chiral center, because you have two of the same groups, but that does not necessarily mean that the molecule is achiral. You have to look at another center. So this is another center. We see Cl, chlorine. So this is a carbon group, which is CH3 here. This is an entire carbon group on its own. And then we have the imaginary hydrogen that we don't tend to write in order for us to like make it a condensed structure. So you have a CH3 here, you have a carbon group here, you have a chlorine here, and you have a hydrogen here. Now these are four completely different atoms, or four completely different groups attached to this chiral center here. So we're going to call this a chiral molecule, because all you need is just one chiral center in a molecule to make it a chiral molecule. But that does not mean that every single center or main center is a chiral center. It could be an achiral center, and then in this case we have another center which is chiral, making the entire molecule chiral. So I'm going to denote that with a C. Now let's do this again. Let's see this one here. We have is this main carbon here is attached to OH, okay? And then this one is attached to CH3. So that's a different group. Then you have the imaginary hydrogen, because we always have to have four atoms attached to the center. So that's a third different group. So a methyl group CH3, a OH group, and a H group. And then you have this ethyl group, which is the same thing as C2H5 or CH3CH2. And you see that ethyl group is different from methyl group, different from hydroxide group or OH group, and different from hydrogen. Hence, this is going to be a chiral molecule. Now we go to the third question. um you have this particular molecule and you have to see this one is not a chiral center because you have two invisible hydrogens here, so this cannot be a chiral center. You have this one too, this cannot also be a chiral center because if you look at it, there is a plane of symmetry that separates it right down in the middle. And this side, the left side, and the right side are the exact same structure. They are mirrored images of one another. So if this plane bisects it, there is a plane of symmetry because here too has like the imaginary hydrogen, the imaginary hydrogen. Eventually, what you end up with is just an achiral molecule because there is a plane of symmetry. Another way you can also look at this, let me erase all of this just so for students that need to see the full picture. I'm going to just quickly do this so that everybody like can think outside the box. Is for you to also look at what is attached to the main center here. You have a hydroxide group OH, then you have an ethyl group, then you have another ethyl group, and then you have the imaginary hydrogen. What did we say about achiral molecules again? Achiral centers again, we said two or more of the same group slash atoms are attached to the main center. In this case, we have two ethyl groups, so that makes it achiral for this center. And then there's a plane of symmetry, and it completely makes it not just an achiral center at this point or at this point, it makes the entire molecule an achiral molecule because of the presence of the plane of symmetry. So that's it. I think well, this like teaches you guys. So I'm gonna denote a chiral with an A in a box, just like I denoted chiral with a C in a box. Now let's do number 4. We have this information here. This is definitely an achiral center. Carbon center is just attached to 3 imaginary hydrogens. So this is another one. You see that here it's connected to to a methyl group, a CH3 group. So just that's just what this is. Like this area is just indirectly saying this is a CH3. So it's attached to that group. And then it's this carbon center is also attached to the chlorine group, and then this carbon center is also attached to this particular carbon group that has a double bond, and then it also is attached to this imaginary hydrogen. So what you end up with is that 4 different atoms or groups attached to the stereo center, which is this one. So that makes it a chiral molecule. If you want to go on to check this one here to see like 4 different groups attached to another center, you can do that, even though I think it's a waste of time because you already know that there are 4 different groups, which makes this a chiral molecule because all you need is just one. So even if there are like multiple achiral centers and you just have one chiral center, that makes it a chiral molecule. So there's that. And we have the same chiral molecule. We have a chlorine group, methyl group, a hydrogen group, and a carbon double bonded group. 4 different groups making it chiral. Now we're going to do the same for number 5. We have this center here. This is going to be an achiral center because we have 2 imaginary hydrogens, so they don't work. Now we check out this one. We see that this particular one is connected to an NH2 group, right? I believe that's called amine group. So like it's attached to this NH2 group. It's also attached to this carbon group, which is just ethyl. Is attached to this methyl group and is attached to this imaginary hydrogen. So you have the NH2 group, the ethyl group, the CH3 group, and the hydrogen. These are 4 different groups, and that makes it a chiral molecule. Now, the next thing you have to do is number 6. I hope you guys are understanding what's going on so far. If you need to rewatch this video, make sure you do so. So, the number 6 one, you have this particular molecule. What you have is like an hexane structure attached, a fluorine substituent attached to an hexane structure, and you're supposed to determine its chirality. So, this one, each one of these centers that I'm doing, like these 5 centers, these 5 points, cannot be chiral centers because you have two hydrogens attached to each one of them. So that makes this particular center as achiral because they're having two of the same atoms attached to each one of them. So that does not necessarily mean our molecule is achiral yet. We have to look at the sixth group. In other form, if that sixth group is also achiral, then that makes it an achiral molecule. And if it is chiral, the sixth one here, then I'm gonna denote with black. Then that makes it chiral. But so now you have F group, you have an imaginary hydrogen group, then you have this side, basically the exact same thing. But then you now see that there's something called, you guessed it right, a plane of symmetry right here that cuts it, that the left hand side and the right hand side are exactly the same. It cuts it right in the middle, and that causes this to have a plane of symmetry, making it an A chiral molecule. So, so we go to the seventh question. We see this one here. We want to see if it's chiral. We can also like think about each one of these centers here before we go to this particular one. All of these centers are achiral because the carbon here is attached to another carbon group and then just has just one hydrogen. So the left hand side and the right hand side is really attached to the same group if you look at it this way. So that means it doesn't really make sense because we don't necessarily determine chirality for like double bonded or triple bonded carbon centers. They cannot act as like chiral centers because we need four single bonds that connected to four different groups, and that defeats the purpose because with double bond you have double bond attached usually to the same atom, so that doesn't really make any sense. So we don't really look at chirality for that. Just a tip for you guys. So that's just a tip for you guys. I'm sorry, I'm trying to redraw the structure of, yeah, the benzene or the phenyl. So now that you have this, we're now going to look at the main chiral center. This situation too is similar, so it's not actually the main chiral center. Apologize, I meant to say this right here is the main chiral center. So if you look at this main chiral center, you guys can pause this video and then watch whatever I'm gonna do. Okay, we're back. So you see that you have bromine atom, right? When you're looking at this, you have an entire carbon group over here that is different from the bromine atom. So you have two different atoms. And then you have an ethyl group, which is just C2H5 or CH2CH3. And then you have this imaginary hydrogen that is always existing, but we don't write it. So you have the carbon benzene group, you have the bromine group, you have the hydrogen group, and then you have the ethyl group. And these are all four different carbon groups. Sorry, you have these are four different atoms slash groups attached to the main carbon center. So this is a chiral molecule, not achiral, but it is a chiral molecule. I apologize. So it's the molecule is chiral basically. Then you have number 8. You have you can from practice you already know you're gonna ignore this center because it's CH3 is attached to three hydrogens. You're gonna ignore this center because it has attached to two hydrogens. The same thing here, the same thing here. But if you look at this particular center, what you see is that this center is attached to a nitrogen group that is attached to like a hydrogen group. So it's attached to this one as a group. So NH and then the ethyl. So that's just one. And then it's attached to this ethyl group. And then also another ethyl group and then a hydrogen atom. Now, I'm sure since we've been doing this for a while, you guys know what's going on. You've got two ethyl groups, two ethyl groups. If you go back to our rule, and achiral molecules have two or more of the same groups attached to the main center. So hence, this is becoming achiral. So that means this center is becoming achiral. But then we also have something called a plane of symmetry, which just basically cuts through here. So that means Like this left hand side here is similar to this side here. Does that make any sense? Because this is just like this N H, and then this dash here is just like one group on its own. And I'm sure there's a different way to write it. You can write it as NH and then you have C2H5. If we write it as like that, then you guys will kind of see what I'm saying. But there is a plane of symmetry where the ethyl group on the left and the ethyl group on the right are mirror images of one another. So that wouldn't work. Hence, this is going to make it a molecule that is not chiral. So it's an achiral molecule. So that's what that is. Um, yeah, that's this one too. So here we've got an A chiral molecule, or a molecule that is not chiral. Let me just redraw the structure for all of you that are taking notes. So you have this, you have this, and you have this. So this is a chiral. Then we have the ninth beautiful question. And the ninth question, I'm sure you guys you know it already. And the answer is just straight up, it is an achiral molecule, because you've got this one here. You already know is an achiral center, because there are three different hydrogens. Is a methyl group attached to this carbon. Doesn't really make any sense. This one is also a chiral center. This is also not a chiral center. So now we are going to the last carbon center in the carbon chain, and you have that. You have this CH2 group. Sorry, you have this CH3 group, also called the methyl group, attached, and then you have this ethyl group, which is the C2H5 attached, and then you have a chlorine group coming out of your screen or out of the page of this particular book. You can think about like your screen as a book is coming out of the page. So, or you can just think about it as coming out of your computer. So you have a chlorine atom coming out of your computer, and then there's another chlorine atom coming out of your computer, but at the back of your computer. It's not coming out of your computer screen, it's coming going away from your computer screen, like almost at the back of your computer screen or at the back of your notebook. So it's going away from you. So one chlorine atom comes towards you, another one is going away from you. And you see that we have two of the same atom slash group. We have two chlorine atoms. So that just makes this molecule not chiral. So we're going to call it A for a chiral. So in total, we've got um, four chiral molecules. And sorry, in total, we've got five chiral molecules. Number one, number two, number four, number five, and number seven are chiral molecules. And then number three, number six, number eight, and number nine are molecules that are not chiral, hence they are achiral molecules. I wish you guys all the very best. Make sure you watch my next video where I'm going to be teaching you guys how to do the R and S configuration for chiral molecules. Take good care of yourself, and Assalamu alaikum wa rahmatullahi wa barakatuh.